This is lesson 9.7, solving a system of equations algebraically. So, we're going to have two equations in our system, y equals x plus 2 and y equals 5. So it gives us the x value, or the y value. So, say for example, Mrs. Y is a teacher at Bald Eagle, and she is calling in sick. So her replacement substitute is the 5. So this 5 gets replaced with that y. So I'm going to substitute the 5 in for the y in the first equation. And now you got an equation in terms of x. So we know that we can subtract 2 from both sides, and 3 is equal to x. So your ordered pair solution is an x comma y. My x value I found was 3, and the y value that was given in the problem was 5. So my solution is 3 comma 5. On the next one, Mr. X is calling in sick, and -3 is its substitute. So I'm going to replace that x in the first one with a -3. So again, it's a one-step, subtract 4 from both sides. The y value is -7. So your ordered pair solution, the x was given, that was -3, and the y value we found to be -7. So always write your final answer as a solution, an ordered pair. So these are an easier level. So now if we have a super substitute here in the next problem, and I'll tell you why it's a little more challenging. First of all, the two equations to start with have a lot more to them. One of the equations does not have like y equals 2. It's a little more complex than that. But we can solve the first one and rewrite it so that this y is by itself on the left side. So in order to bring this -3x over, I have to do the opposite and add it. So I can rewrite this one as y equals -13, and we can add 3x to the other side. Alright, so my second equation I'm just going to rewrite again so they're underneath each other. 4x plus 5y equals 11. So, again, we have a teacher calling in sick, Mrs. Y. Say, for example, she calls in, she has explosive diarrhea that day, so she needs a super substitute to really come in to do her job. So, -13 plus 3x is the super substitute. And we're going to put that in the second equation where the y is. So I have 4x plus 5. Instead of a y, I'm going to group this and put my substitute, -13 plus 3x, and set it equal to 11. So all I did was I replaced that y with its substitute. And we can just solve this like we have done before with solving equations. Distribute the 5. So it's 4x plus, well, actually subtract 65, 5 times 13, plus 15x equals 11. You can add 65 to both sides, and you get 4x plus 15x is equal to 76. Combine the like terms on the left-hand side, you get 19x's equals 76. Divide both sides by 19, and x is equal to 4. So that's only half of my ordered pair. Remember, we need an xy. So I'm going to substitute my 4 for x back into one of the original two. So I'm going to choose the first equation. And we're going to look at the way we rewrote it. So this is -13 plus 3x. So that was the top equation solved for y. So instead of an x, we're going to replace that x with a 4, because we think x is 4. And this will be y equals -13 plus 12, and y equals -1. So your final answer the solution is the x value was positive 4 and the y value was negative 1. So that is your final answer. So this was a harder level type of question than these two, where we had one number that was already given to us. So the second example, we had to do a lot more work to solve for that. All right, well, we have two more examples. So the ones we just did that have an ordered pair solution, those are like, if we had to graph them, they would intersect at a point. Now the next two examples are going to be like the parallel lines and the same line. So if I need to solve this system, you have y equals x plus 5 and 2y minus 2x equals 10. So y is calling in sick. The substitute is x plus 5. So I'm going to replace that y with x plus 5. So that's the first step. Then distribute and solve for x. So this is 2x plus 10 minus 2x equals 10. Well, if we look here, 2x subtract 2x becomes 0. So then you just have 10 equals 10. Well, this is always a true statement. 10 is always equal to 10. We know that. So when it is a true statement, your solution answer is not an ordered pair. It's infinitely many solutions. So if you were to graph this, it would be one of the graphs that are the same line on top of one another. Okay, so I'm sure you can predict about a false statement, but let's look at an example. You have x minus y equals negative 4 and x minus y equals positive 1. Well, if you notice, this x minus y and x minus y are the exact same thing. You can't have the same thing on the left be equal to two different numbers on the right-hand side. So this has no solution. Okay, if I were to actually solve these out, I can rewrite this bottom one for y, so add y to both sides. And this could be rewritten for x as x equals 1 plus y. The top equation was x minus y equals negative 4. So again, the teacher calls in sick. X wants to stay at home and rest up. So 1 plus y is the substitute for the x value. So you could have 1 plus y minus y equals negative 4. Well, y minus y, that's 0. So you have 1 is equal to negative 4. Well, we know that that is false. So when you get a false statement, like I said, it is no solution. So if I had to graph this one, it would be the one that has parallel lines because they never intersect. So a true statement is infinitely many, false statement is no solution. And this happens when your variable term dropped off and you only had numbers at the end and you had to determine whether they were true or false.